Okay, so now we're going to talk about design a little bit. Design is really just an extension of evaluation. And what I mean by that is evaluation of a problem really, as you saw in those couple examples, evaluation really hinged on stirrup spacing, right? So what's design all about? Stirrup spacing, picking the right stirrup spacing. I mean, that's basically it. So all we're really going to do is go through sort of an extension of what you've already seen. The one thing, and this holds true for any type of design, what do we consider being okay as far as the design goes? Well, for shear, what that means is your design capacity has to be at least equal to V sub U. Could be greater than it. I mean, we had a couple examples. We saw where our VVN lines are over VU. Great, no problem. Okay, but we got to be at least equal to it. If that VVN line drops below VU, then we're in trouble. Okay? So we've got to hit at least that. We've got to meet this. This has to be. There's other things that are involved, you know, maximum spacing, where no stirrups are allowed to be used. But in general, I mean, this is the big piece of it. All right? By the time we get to shear design, how much stuff do we know? Do we know what B is? The width of the beam? Yeah. Do we know what effective depth is? Yeah. Do we know what F prime C is? Yeah. Do we know what Fy is? Yeah. Do we know what kind of stirrups we're going to use? Yeah, basically. I mean, they're either going to say use number 3s or number 4s. Probably for ours, they'll always say use a single U-shaped stirrup. They could say use a double U-shaped stirrup, but I mean, you know, whatever. You're going to know that. You know, if you look at V sub C, 2 square root of F prime C BD, you're going to be able to calculate that at the beginning of the problem. If you look at V sub S, AV, yeah, I know what that is. Fy, know what that is. D, know what that is. The only thing you're doing in design is really designing the spacing. That's it. All right? And where it really gets easier than that is the only spacing that you really calculate for is going to be the initial spacing. So the calculation of the initial spacing, and what does the initial spacing of stirrups have to guarantee? That you exceed VU critical. VU critical is the critical shear. We've already talked about how it occurs out a distance D from the support. The one spacing that you actually have to calculate, you know, down to the decimal place, what it is going to be the initial spacing. Now, we can come up with 6.27 inch spacing. We're not going to use 6.27 inch spacing. We're going to use what? 6. We'll always round down, okay? We don't generally, for stirrups, we don't use anything but whole numbers. And even that being said, a lot of people would use a whole number that, you know, might give them some sort of even arrangement, you know? Like the 6 inch spacing I was using before, that's sort of nice because, you know, you can count 10 6s and say, oh, that's 60 inches. You know, that's 5 feet. You know, so, but nonetheless, I mean, we never use decimal or fractional values of spacing. We always use whole numbers. All right? But the initial spacing, how would we calculate the initial spacing? Well, we got to beat VU critical, right? So, it's really going to be a two-step process. The first step, and there's different ways you can do this, but this is the way I tell you to do it. The first step in this process would be to calculate the VS that you need. Okay, you might even call this VS initial if you know, doing it on a piece of paper, but you're doing it for the initial spacing. VS initial will be VU critical divided by phi minus V sub C. Okay? You know how to get VU critical. You know what phi is for shear. You know V sub C, you can calculate that going in, no problem. Where in the heck did this formula come from? It's a crazy looking formula, isn't it? Or is it? Let's see, if I add VC over here, that cancels it out, but I got to add it over here. VC plus V sub S. If I multiply this side by phi, it cancels out the phi, but I have to multiply this side by phi. So I got phi times the quantity of VC plus VS is equal to VU critical. Oh, that was sort of that, wasn't it? Well, that's step one. How much V sub S do you need to make this happen? Step two is just to rearrange the V sub S formula and solve for spacing. And you can call this initial spacing if you like, or just, you don't have to say initial. But it's AV Fy D divided by Vs initial. And again, you don't have to put the word initial down there, but I'm just trying to reinforce the fact that we're talking about the initial spacing. Okay? Where did this formula come from? Just a rearrangement. You're used to seeing V sub S is equal to AV Fy D divided by spacing. We just are solving for spacing now, and now we know what Vs we have. Okay? This is the way you're going to calculate the initial spacing. This is the spacing that's going to be needed to beat, VU critical. Now again, this is going to come out to be some decimal number, 8.19 inches. We don't use 8.19 inches. We always use what? 8. You always go down because as your spacing goes down, what happens to your capacity? It goes up. So this is supposed to be a spacing that will exactly make this happen. But if we use a spacing that's a little bit smaller, then this becomes a little bit larger. And so it's okay to be greater than or equal to. Okay? That's the way you're going to find your initial stirrup spacing. Now I said that was the only spacing that you're going to have to calculate. Because what do you think, design, there can be a number of answers when we start talking about design. This is the one that everybody has to have the same. What do you think, where do you think design goes after this point of view? Or this particular point that we're working on right now?
Go back and check it.
Well, you could go back and check it, but as far as design is all about spacing. So after you get the initial spacing, what are your choices in design?
Figure out what size stirrup you want.
No, because that had to happen before as we got into this point.
Where does stirrup start and stop?
Well, the initial spacing, the first one's going to be probably half a spacing out from the start. But yeah, one thing is, can we cut stirrups off? So how far out do I need to run my stirrup? Here's the questions you got to ask yourself. Are you going to keep this initial spacing the whole length of the beam? Or is there some place that you change spacings? You have to answer that. Well, maybe I'll make you answer that, but you have to answer it. You got to know what your maximum spacing is, because you don't want to design a beam and say, hey, use this spacing here, but then find out it's over the maximum. So there's these little odds and ends, but hey, I got 20 people in here. You could all end up with slightly different designs, and you could all be correct.
Do they ever increase the spacing each stirrup just to keep that envelope directly above the?
No.
They don't.
No. I mean, if you're gonna make a spacing change, you make, you know, a change that's, makes an impact. You know, we don't go, now, I'll say that, you know, read the book, or they'll do an example, and they'll say, oh, we're changing from 6 inches to 7 inches to 9 inches, or they'll do something like that. That's crazy, all right? If you're gonna make a spacing change, make it 3-4 inches, 6 inches, something like that. I mean, do what we did in that second example. Go from 6 to 10. 10 was the maximum spacing. Make that your change. Don't go from 6 to 8 to 10. You can do that. It's just that, you know, I mean, when those guys are out in the field, they're laying these things in. I mean, the difference between 6, 8, and 10, you know, I mean, you can put them in there, but make it a large change, a noticeable change. So we can design things down to the 1/4 inch, you know, mark, but we don't. So make it substantial.